Balvikan Bharti with Abhilash Sarkar. In this chapter, we will move on the problem number 36. This problem is basically a problem is based on the application of grid statistics. So you will get some more conceptual ideas from this problem if I solve it for you, and it will be a new learning that is not covered in the theory part, but definitely a you can say the more concept that will help you to solve uh, some advanced problem or some conceptual problem that could be useful for other segments of the subject. Okay, so let me draw it first. So there is an aquarium, you can say. One part of this having some glass window. This is denoted by A and B. Some water is filled inside this. This window, glass window, is kept to view the inhabitants inside this water. This dimension is given as 2 meter. The further dimension up to B is given as 3 meter. So this is the simple diagram is given. And now the sum says force on submerged window AB, which is used to keep eye on inhibitants. Okay, so the dimension is 3 meter cross 1.5 meter. So 3 meter you can see here, and 1.5 meter is on your surface. So on the perpendicular to your surface, you can assume it. Okay, this is that, and density, as it is water, is 10 to the power 3 kg per meter cube. As you know, obviously, find the force of water. Find the force of water on window AB. Okay, so in this part, what is the force? Okay, fine. And the location of the equivalent point load. So this the equivalent point load, that means now in this window there is a force acting is this much. So that means whatever the pressure is there, the pressure will vary from due to the height of the water column from here to here, and that whatever force is creating on that, if I assume a concentrated force, the equivalent amount of effect will come on the window at which height this is acting, that also you have to find. So first thing is you have to find the total load acting on this window, and if the load is said to be or considered to be point load, let's say F is pointing at this height, what is this height that you have to find? This is the second. The first, now for general concept, let's say this is a wall, along there is any liquid there, and the pressure here is P1, there is P2, and P2 minus P1 is what? H rho G. This is varying with this height of the liquid column. This could be, let's say, H. Other part rho and G is considered to be constant as incompressible and ideal fluid. So G as we are considered to be in a same location, this G is not varying, rho incompressible, for any effect of pressure it is not varying. So this part is considered. So this we can assume to be Y, and this considered to be a constant M into X. If I compare this is a line, a straight line that is passing through the 0 0, that means the origin of any coordinate system. This is Y, this is X, this is independent, this is dependent variable, and this Y is dependent, and this is M is equal to. So this is resembling some linear equation. So you can say, and this, if I draw, this will be somewhat, this is the value of X, or other way you can say this is the value of X for which we'll get some Y every time, because this is independent variable, so we vary Y. So here what we are varying? H, we are varying X, and what we are getting? P. P is increasing, but this is increasing with this linear equation. So this is uniformly increasing from 0 to the highest depth of the fluid column. In this case it is water column. So similarly, if I consider it on this problem, we will get a similar triangle. The triangle would be how it is from there. If I go up to B, because I will be interested more on this part. So this with this will something be like that. So in that area between P and PB, what is pressure at PA is equal to, your H is 2 into rho is 10 to the power 3, and G you can take 10. So 2 into 10 to the power 4 pressure is Newton per meter square. It is acting. That of PB is equal to 2 plus 3, 5, and other thing will be same, 10 to the power 4 Newton per meter square, this much. So these are P and PB. So now in this area, if I draw it something like that in a bigger scale, this is your PA, this is your PB, and in between this is uniformly varying. This is varying but uniformly varying. So if something is varying uniformly and related linearly, so we can take what is the effect of the pressure. What is the formula of force? Force is nothing but pressure into cross section. But in this case, what pressure will take? As because pressure is varying but uniformly varying, so what is the effect of that varying pressure? It is, you can say, this is the average pressure of between the P maximum and P minimum. There in this zone, P minimum is PA, P maximum is, so your average pressure is P max by P min every time, or any scalar deviation or vector deviation which is uniformly varying, it is the P max plus the P min by 2, the variable, the maximum value plus the minimum value by 2, it is the average value. So this is, when P is varying, we will take P average into the cross section. Into cross section is equal to what? Cross section of the window on which the pressure is acting. But window is something like that. This is 3, this is 1.5, this is 3, so this is 3 into 1.5 further, so this much. So this is equal to P plus PF is this, you add 7 by 2, 3.5 into 10 to the power 4 into 4.5. So this will be your force. You can calculate yourself. Now, if this force is acting at as a point load at somewhere, so what would be the location? So now, if I extend it, and the pressure will definitely be acting in this point load will definitely be acting in this part, because that cannot be somewhere here, because that effect will not come on the glass, neither it will below down the windows, it will act somewhere. So you can assume this is a point load F, it's acting, let's say, at height h. So how this h will go? Now this height h, how will I get? So this is the formula to get h, which is coming from the finding of the CG for any composite figure. This for composite figure y. Here y I am taking because only variation of the pressure of the force depends on the variation of the height. But in any height in that zone, if I take any cross section of this height, due to the height, the effect of the force will vary. But in this plane, anywhere you take this concentrated load, if I shift it here also, the effect of the force on the window will not vary, because that will be in the same plane. Only thing is that if plane changes, so that means height changes, so only y will vary, x will not vary. So the value of x, value of y, if I am able to find, that will be calculated basis on this y into hy by that area of, this is area into height of that figure. So now y I am taking the sum to get h, but definitely y, that means equal to, will get the h here. This is representing y. So what is this area of this composite figure, which is being created by the pressure and the height dimension. Now it is composite. Why it is summation of all this? Why this different figure will come? Here if it is a uniform figure, that area will be same. But here this is varying. This can be divided into two parts. This is one rectangle, one triangle. So how that area of varying for this rectangle, and the area is created by pressure. This arm, this dimension is the dimension of the pressure, and this is the height. So for first case, when it is rectangle, the area will be PA into height of this, I will take it is 3, and then this is the CG of this figure only. This is summation of area into CG. Center of gravity of this rectangle figure will be at center. So this is from top, it is 2 meter, plus this is at center, that means half of the 3 meter, that is equal to 2 plus 3, that means 3.5. So this will be the case. This will be calculated by the basis of the area into the CG of the particular figure, plus why I am taking sum, because this is distributed into two figure. So for this is again triangle. For triangle, what is the pressure energy I have taken? This is uniformly PA. This part, if it is a rectangle, the opposite arm also it will be PA. But what would be this case? This is from 0 to PB minus PA. Okay. So what will be your area? Area of a triangle, that means half into base. That means this. So half into, if I take base is equal to 3, okay, into altitude means this height is equal to nothing but PB minus PA. For understanding, I am just writing this PA part, because PA part is very confusing. So area I am getting the pressure into the height. So this cross section for rectangle is side A into B. So what is A? PA. B is 3 meter. This part is over for A. This part is for CG. Center of gravity is half of the, because it is uniform figure, half of the length, because it is deviating, it is varying with height of this part, not this part. This is varying. So this is 2 meter. It will be added plus what is the height of the CG? Exactly 2 meter plus half of this part, 3 point. This for triangle it is half base into altitude, means PA. This part is height is PB minus PA. This is total is PB. This part is PA. So this part is PB minus PA. This is over area into this CG. For any triangle, this is how much? The CG is acting at 2/3 from the vertex. So 2/3 means from 2/3 of what? 3. So that means it is 2. So this is 2. 2 plus 2. It will be somewhere there. It will be 4. So this is over divided by. What is A? Area of this again. This is again this part plus this part only. This will not come. So instead of doing that, this is what? This is a trapezium. So we can say half into side, parallel side, plus PB, parallel side into height. This will give you the same thing. Area of the trapezoid is half of sum of the parallel side into the distance between that will give. So now this, if we calculate, PA is equal to 2 into 3 into 3.5. I will keep it somewhere outside, because this part from top and bottom it will be cancelled. So I am not taking it in consideration. So this will be 2 PA into 3 into 3 plus 3 by 2 PA minus PB minus PA is only 3. So this will again 3 will come into 4. Okay, 10 to the power 4 linear will be eliminated. So this is half PA plus PB. This is 7 into 3. So this much will be there. So now calculate this. 3 to the 6. 6 into 3.5. 30, 18, 21. 21 plus 2, 3 to the 9, 2 the 18. Okay, this is 21 and I will multiply, this is 2. This is 21, 20, this is 9, 39 into 2, 21. So this will be 78 by 21. So approximately how much will come? 321, 78, 363, 51.0, 21, 7, 21, 7, almost 7, 14, yes, so almost 3.7. So at what point this will be 2 plus 1.7 further, at around 3.7 meter of height. If that load is concentrated, it will act at this meter. This will be the answer. Understood? Okay, we'll move on to the next problem, that is problem number 37. A concrete retaining wall 3 meter tall and 0.8 meter thick encloses wet clay mud. Find the maximum depth H. Find the maximum depth H of mud that can be retained without tipping the wall. Assume density of mud is 1760 kg per meter cube and density of concrete is 2400 kg per meter cube. So this is the diagram. This is concrete wall of height h and the dimension is given, it is 0.8 what meter. This is a meter. This is concrete wall and this is having ground and the mud height is this is 3 meter. Mud height is h. Okay, so here if I draw the pressure diagram as we drawn in the last sum, the pressure diagram on this concrete wall due to the mud, as mud you can see as a semi-liquid or it's a fluid kind of thing. So at this height the pressure at the top of this will be 0 and slowly it will increase. So this is the pressure line which is increasing. You can consider like that. This is 0 pressure, this is maximum P max. Okay, so this way the mud is creating a pressure on this. So what are the cases that it will fall? This concrete wall, as it is uniform, I can see. So this having some center, let's say this is 3 meter. So at 3 point this is 1.5 meter. This is having CG. So this is acting downward. This weight, which is giving a stability. This is downward weight of the concrete wall. As because this has given a set thickness, so as because this is uniform, this is acting exactly where the coordinate of this will be 1. The thickness, if I say this is 0 0, against that this will try to topple. This is your 0 0 point. Okay, So now against that, this point will be at 0.4 from there, comma, height is 1.5. So this will be the coordinate of W. There it is acting. Okay, and this pressure, as because this is varying with height and this is having height of H. Okay, so that pressure difference P max minus P, I'm just not considering the atmospheric pressure, P, this there is P0, let's say, this P max and P min, this is P min, let's say, is equal to H into rho into G of the mud. This is mud, this is variation, this is the triangle it is forming and as because this triangle, if it is the concentrated load is acting on that wall having, let's say the depth of the wall is depth we are assuming of the wall is dw. Okay, so this we can consider because this dimension is same for mud and the wall, so this is depth. Fine. So the mud is acting from 0 to max, and if it is a concentrated load and it is varying uniformly, as we can see, I have seen in the earlier cases, that the load will act at what point? It will act at from vertex to 2/3 of H, that concentrated load. This load is acting on, that force is equal to the delta P, you can say delta P into the cross section is equal to what will take for mud, it is depth into height, H into D of W, depth of wall will take. The force is acting on the delta P, the variation of the pressure, delta P, the average will take. The average will be the average is equal to the P min, we are assuming to be 0 because at the top this will be the half into P max into the cross section of the wall that is contacting with the mud. The mud is dw is the width into the height is h. This is the force. This is the force due to the mud, and this is acting at what? 2/3 from the top. So that means from this point it is acting at somewhere 1/3 from the ground. Okay, so force is acting. So as the wall is stable, so that whatever the moment, the force due to this mud is acting clockwise, it will be balanced by the W with anti-clockwise direction. Now this is the intersection of their point. So against this point, that the force will be, the moment of the force will be same. This will be the intersection of this line. This is the force acting at 1/3 from the height. So this will be the height, because height you have to consider from there. The moment I am considering this side. So force is acting. This is the force due to the mud. So the force due to the mud into the height is 1/3 of the h is acting clockwise. It must be equal to the force due to the concrete wall, and it is acting at this point downward, this way. So what is the force acting? The moment is this into the distance, because from there I have considered both the distance. From there I am considering this height into the moment. The moment coming here, this is the force to the mud into the height. This will give you this much of moment. I am talking about the origin. Against the origin, this is the force and the moment. This is h/3 into the mud column. This is creating, and against this force, this is the WC and the distance. So this is trying to put it back in the location, and this is trying to wipe it, taking out. So that moment will be same, 0.4. This will be the moment for this. This must be same. The Fm is equal to half into P max is equal to P max is equal to H rho G, H of the mud, this is H total into rho of the mud into G into 1 H by 3 we have taken. This is equal to weight of the concrete column. Weight of the concrete column is the volume of the concrete column. The volume is equal to the height 3 meter into this width 0.8 into dx, the depth is equal to dw we have taken. So dw flows into this force we have not taken full. This is the P max we have taken into dw. This will come again dw into the height. This is the total force I have not taken. Half into this is the force P max. P max is equal to H rho G into dw into H, that will come into H into the momentum H by 3. This is equal to 3 into 0.8. This is the height, width into dw, that is the volume. Volume into weight is equal to rho of the concrete column rho into G, that will be the weight into this 0.8, this 0 point, this will be 0.4. So let me rub this to get the total figure once again, so that it will be clear. What I am writing here, half about the P max, half into H of the mud, half, this is half P max. P max is equal to H into rho mud into G mud into the cross section dw into H into arm is equal to H by 3. This is the Fx into this one, and this is equal to volume 3 into 0.8 into dw, the weight, this is the volume, into the row of concrete, this will give the mass, into G will the weight, into the 0.4 will be the momentum. So now this is finished. So now the part that will be there is this much. Now what are the useless things? dw, this is equally participating both. What else? Okay, let me, I am not, this is the commonly I am writing H, 3H. So H cube by how much? And G also will consider, G will not take, 3 into 2, 6 into row of mud. Any other thing? No. Row of mud is how much? Concrete 17, 60. Anything else? No. H gone, 3, 2, row of mud I have taken. Okay. On the right hand side, this is equal to 3 into fine 0.4, 3 into 2 if I take, so 6 I'll do, 6 into 0.4 square into row of concrete is 2400, this much will there, and now fine. So what is your H cube is equal to 6 into 6 square into 0.4 square into 2400 into 7 into 60. I will take it out, 6 into 4, 24, so that means 2.4 whole square into 24 divided by 176. Okay, so H cube is this much, so I will write H cube is, so H cube is equal to 2400, 24 cube I will write 10 into 10 will be there, 10 square, that means it will go below 10 square, 24 cube into 176. So this will 176 cube root, 24 will be there, 176 cube root, that means 2 11, yes, 11 1 11 6 0, anything else, 60 60 280 240 220 210 25. So that means 1 2 3. So h will be something cube, that means 24 will be there, and below this 176 0. So 3, that means 2 will come there, 2 2 5 11 56. So that means 10 into 2 20, 20 into 11 220, 220 cube root. So this is something, this will come. Okay, so if I want to able to cube it, it will be something 6 6 around 6 will come, because 6 into 6 into 6, so that is 216. So that means almost 6 will come. So if I take the approximation of 6, 2 into 6 around, approximate, this will be 2. So the H of the mud, so what is the case? The concrete retaining wall 3 meter, find the maximum depth of the mud. So depth of the mud will be maximum 2 meter, because I have taken 6 approximation, it will be more than 6, so it will be something less than 2. Okay, if I take 6 approximation, so 220 is not approximately 6, so it will be more than 6. So more than 6 means is less than 2 will come, so less than 2 meter. Height of the depth has to be maintained for this. Okay, so I will end up here. In the next video I will move on to the problem number 38 and onwards. So thank you for now. Good night.